Hello, thank you for joining us today. We're just going to wait a couple more moments for people to get into the room and settle down. So we'll start in a little bit. All right, I think we'll go ahead and get started. So hello, everyone. Thank you for joining us today. I hope everyone is staying safe and healthy. I am Sharona Bollinger from the LGO admissions team, and I'm very excited to welcome Bruce Lawler, an LGO alum, and Felix Dumont, a current LGO second year for today's event. We'll hear from Bruce about the new MIT MIMO program, followed by Felix, who will talk about his research, his recent internship project that focused on machine learning in an industry setting. So as we go along, please feel free to type your questions into the Q&A function, and we'll address them towards the end of the webinar today. But before we get into the meat of today's webinar, I wanted to give a quick overview of the LGO program, just in case anyone is new to our events and is here to learn more about the LGO program. So the Leaders of Global Operations program is a dual degree between MIT Sloan School of Management and the School of Engineering, where you earn both an MBA and a Master's of Science in Engineering in one of 8 disciplines. The program is a full 24 months. So each cohort starts in early June, and the first 3 months of LGO are spent doing LGO specific curriculum with your classmates. So a mix of engineering and business classes, some leadership development, and a lot of industry networking. LGOs are then fully integrated into Sloan and their engineering department and take a mix of business and engineering classes throughout their time. While pursuing 2 degrees is certainly a big commitment of time and energy, our students have a lot of flexibility and choice about how they spend that time and energy over the 2 years. One unique component of our program that will be highlighted today is the 6-month research internship. So every student completes a required and guaranteed 6-month internship with one of our industry partner companies, where they work on a project or help solve a problem with that company. The scope, topic, focus, and solution to an internship project are as varied as our students' interests, and the research conducted over the 6 months is the basis for the master's thesis. So if you have any questions or want to learn more about the program, please check out our website, lgo.mit.edu, or feel free to reach out to us at lgo@mit.edu. We're always happy to answer questions at any point in the process. So with that, I will go ahead and pass it off to Bruce to really get into the content of this webinar.
Great. Well, thank you everyone for attending. My name is Bruce Lawler, and I'm in LGO 92, one of the very first classes. I went off and did my career in manufacturing, and then was a software entrepreneur and created companies, founded companies that both went public and were sold to other large corporations. I was also a VC for a while. And now I've come back to MIT to help bring machine intelligence into manufacturing and operations more rapidly, because my observation is it's not happening fast enough for the industry, and we want to do whatever we can to make it happen faster. So what we really try to do is try to find the shortest path from data to impact, and this is our landing page on our website, so you're welcome to come and take a look around. It's still a work in progress, but we'll give you some more information. So what is MIT MIMO, or Machine Intelligence for Manufacturing and Operations? So we have it's really a research and educational program, and we want to increase industrial competitiveness globally, but really more we're focused right now today in the US of how we bring machine intelligence into manufacturing and operations. So there's three components: a research component, which is really field-based PhD research and master's research in manufacturing and operations. There's an education component. Once again, it's for both PhDs and master's students, so specifically LGO students. And Felix is a great example who will talk later to give you an idea of exactly what you might work on in the program. And then collaboration. So we really are striving for authentic collaboration where people are all working together to learn. And I'll talk a little bit more about one of our research forums that really bring together students, faculty, industry to talk about the problems. And so the ultimate objective is really a transformation in manufacturing and operations of machine intelligence, bringing machine intelligence into manufacturing and operations. So we really focus on three different areas. So it's not just data science, which a lot of people might jump to, but in order to be successful, you really need the engineering component, the management or the people component, and the core technology. And so it fits very well with the LGO leadership aspect and having the dual degree program. So from the engineering side, we have the subject matter expertise, physics-based modeling, and we look at how processes might be transformed. On the management side, leadership, really looking at the human interactions, and then how do you deploy it? How do you look at the full data flow? How do you change the processes? How do you change the methods and procedures, the cultural issues? How do you retrain people or reskill them to up-level them? And then lastly, what most people think of, the technology, the data science methods, digitization, and then data transformation and workflows. So those are the three big areas. And what we try to do, there's a lot of talk about, what's the work of the future. There was a great conference yesterday called AI and Work of the Future Congress, and the videos of that will be posted soon. But that's a really good, if you're interested in this area, really good website to check out. But when we look at machine intelligence, we're really trying to create superhumans that can make better decisions faster with better perception and richer information, or we're trying to create super jobs. So, how do we and offload the more fatiguing, tedious tasks to computers? And we try to do both those things by augmenting perception, using analytics to accelerate decision making and decision support. And lastly, to automate really repetitive tasks like an inspection task. You're looking at the same thing all day. Well, a computer can do that and then allow you to focus on anomalies that perhaps a computer can't see. And then how do I innovate? How do I change the process to not have anomalies? As far as our research component, we really right now are focused in two areas: intelligent supply chain and intelligent manufacturing systems. And if you want to break those down, in intelligent manufacturing systems, we're looking at process monitoring and controls for both continuous processes like chemical processes, and then obviously unit processes that most of you are familiar with. We really look at mixed data type issues, so ensemble types of solutions. It's very rare that I can take just one data type and use it to solve some of these more complex problems. And I'll give you an example of what we're doing with a major automaker on that. Obviously, digital twin models do a great job of giving you kind of the what is or what should be state and allow you to compare the what is state and make changes based on that. Anomaly detection, a lot of people look at that as predictive maintenance. We're doing an interesting project with a chip manufacturer on anomaly detection using only known good data. And so I'll go into that one a little bit more. And as I mentioned before, bringing the human into the process is extremely important. So human in the loop. We've got some great faculty that we're working with, and many of these also work with the LGO program. So they could definitely be thesis advisors for some of you. I won't go into the detail on all of them, but they're very, very excellent faculty here at MIT. The next area we look at is intelligent supply chain. I think in COVID times, this has come really to really gotten a lot of attention, especially in the area, the second bullet here, supply chain resilience, flexibility, and risk management, but also omni-channel operations. So this is the ability to get the products you want in new ways. So obviously we've all changed how we've procured things. So, you know, an example of this would be like Nike. Right, you can go into a Nike store or one of their resellers, or you can get things from Nike online. And you know, how do they manage the inventory for that to really give you the best experience? You know, as we move toward digitization, we look at really how do we link supply chains together? So how can I sense the things that are going on in the supply chain? How do I make it transparent? And then how do I trace the actions that have gone through the supply chain, knowing that privacy is very important. A vendor to me doesn't necessarily want me to know everything about their business, but enough so that I can make the right decisions. Obviously, to support that, we need digital supply chain platforms that can keep track of this data and maintain privacy. You know, some people are using things like blockchain for that, but it doesn't necessarily have to be a blockchain type of solution. And then lastly, dynamic pricing and promotions. So as you know, pricing on things seems to change more than it used to, a lot more sales and promotions. So when do you do those? How do you do them? How long do they last? And then what effect does that kind of surge in demand have on your supply chain? And then obviously, how do you pay for everything in your supply chain? People are getting very innovative there. We have great faculty as well working in this area with specific interests. Certainly, like Joanne is focused on the sustainability aspect of it, as well as transparency. So varied interests, all very complementary, but lots of interesting work being done there. Let me talk about a specific project here. So this is Semiconductor Production. And this is a particular process called plasma etching. So you're really etching off layers of the chip itself. You know, there's hundreds of layers in an individual chip, and every layer is different. So there's thousands of different processes, or they call them recipes, to do this. And the challenge is it can be up to 3 months from the time you do etching, or ion implantation is the other process, on any one layer until you can actually test it. So you get a tremendous amount of work in process, and you end up scrapping a month's worth of product if something goes wrong. So it's a super important process to understand when you have things going wrong. But things generally don't go wrong. It's very rare that they do have defects. It's just when they have them, they're very expensive. So this particular project is, how do I train models using only known good data to detect when a process has actually gone out of control? Or maybe it's still in control, but for a brief period of time, it's making bad product. So in addition to determining that, we then have to look at changing process dynamics like concept drift. So things always change over time. How do you update the models to represent that? how do we then get ahead of the problem, right? The first thing is to identify it once it happens, but then how do you alert before it happens in case something can be done? And then the final phase of this project is how do I transfer this technique to new recipes and new tools that really don't have any historical data. So this is a research project. It's a 2-year project with one PhD student and faculty. And then we have actually a data scientist at the partner company. They're working cooperatively on this. And we're just at the phase where we're starting to implement in production kind of the first phase of this. So that's an example of research. This is another project that will start early next year. This is again, a 2-year project with 2 PhD students. And we do hope to have LGO students work with them as well in a similar capacity as what Felix did on his internship, only this obviously would be at an auto manufacturer. The problem here is they're putting in a whole new engine manufacturing line for a brand new type of gasoline engine, which has a lot of really phenomenal properties to compete with electrical motors, which, we could all say, why are you doing that? But I think we could agree that there'll be kind of a long tail on gasoline engines. They will ultimately get replaced, but we're 10 to 15 years from that. So for this particular new engine, we're creating a virtual quality gate. So they have thousands of pieces of data. So they've got incoming component data. What are the measurements, the surface roughness, the ovality, assembly process data? What are the torque values, the pressure values as things are pushed together or tightened? And then actually the quality confirmation data when they run it through their test fixtures, what kind of data do they get out of the performance? And our goal is to determine at kind of a higher level what problems are there with this engine, because they do know there's some modalities of failure for an engine like this that they cannot detect with any of their current processes. So our job is to find out of the thousands of data points which features matter the most, and then track those. So we're looking at component and sensor data, instrumentation, the model creation data, validation, and I won't get into any more detail because I'm going to run out of time and I won't get through all the other things. But this will be a really fun project, and it's a unique opportunity because in this particular case, they're removing a 20-year-old line to put this line in. So it gives you an idea of how long these engine lines stay in production. Once again, another type of research. Now moving on to kind of the educational component. We run a deep learning workshop every year. In 2018, we did a defect detection in biopharmaceuticals, and it was actually based on a 2019 thesis at Amgen. It was actually, that thesis was in process when we did this. And so AWS sponsored it. We used one of their deep lens neural network cameras, and actually it's a GPU and a camera together. And in 2019, we did false positive rejection of PCB assembly. So this was an NVIDIA problem, and they were putting chips to actually make their NVIDIA Jetson boards, their edge GPU, but the capacitors would get misaligned. And traditional processes rejected more boards than they needed to, so they actually put in a machine learning separate process step to take all of the boards that were bad and determine which ones were really, really bad and which ones weren't, and that saved them a considerable amount of rework and expense. And then this year, we're going to do applications of AI for predictive maintenance. Once again, this is NVIDIA is going to sponsor this, and so it'll be a one-day workshop. This is all, these are live workshops. So they're written in Python, implemented in Jupyter notebooks, and you can play with the data live as you go through the workshop. And if you want to make changes to it, you certainly can. Then we're also bringing in back some LGOs to give some example use cases of what their theses were in predictive maintenance. So we've actually expanded it to a 2-day workshop this January. So another example of education is we've taken all of the theses, which are very academic, very detailed, typically 50 to 100 pages in length, and we're breaking them down and making them more accessible from a business perspective. This is really designed for business leaders to see, and it's great for the students to actually put this up on their LinkedIn profile so that people can understand what they did. So this was an example thesis on, what is the impact of raw material variability? And we just broke it out in terms of the business problems, the approach, the impact, and then, on the right-hand side, what types of data, what were the drivers, the barriers, the enablers, key actions, best practices, et cetera. So we're building this into a database that industry practitioners can search through, not only by job function, but KPI and use case. We also have lots of different tags in terms of data types and machine learning method used. So that's part of our educational program as well. And then we have a project we just started this semester, which is the Student Research Forum. And it's a weekly discussion where we bring together MIT PhDs from different engineering schools and the Sloan School, and then speakers from industry to look at real problems. So we'll bring in an industry person to talk about their problem, then have a PhD that perhaps is working on that particular problem, talk about the different approaches they're taking, and then do a little bit deeper dive on what they're actually working on at the time. So the objective here is to look at how do I solve this problem in different ways. So we bring different students in that are working on similar problems, but solving them in different ways. And then lastly, we want to obviously enhance the collaboration from industry. Our goal is so that when you come out of the program, you can actually go solve problems. And so we want to have you see a broader set than you might actually see within your thesis itself. So, and we do want people to see, you read a thesis and you get really only the result. We're doing this throughout the semester so that you get kind of that work in progress kind of perspective. So that's been a really popular program. And here's a couple of examples of, the discussions going on here in terms of the work that the student is doing and the approaches that they've taken. So with that, I'm going to stop and I will turn it over to Felix to talk a little bit about his background and then the project that he's working on, or worked on, sorry.
Yeah, still working on a little bit. Thank you, Bruce. So we'll now share my screen. All right, assume everyone can see this. All right, take that for a yes. So I want to talk about my recent project that is actually the basis for my thesis, which was at Amazon. So from February to August or so, that was there. And I will go through some examples of how you can leverage deep learning for manufacturing. In this case, Amazon is not manufacturing, but is actually often treated as such. It's kind of one of the philosophies there of their entire operations. So I'll go through some of those examples. And I think there was a question in the chat of how can LGOs be involved in this kind of work? Well, hopefully this is a good example, but there's all kind of different projects that really focus on this type of work. So I will explain in a minute what the project was about. The title may sound a little bit cryptic. This is actually the title of my thesis, but it's called Supervised Learning Models of Scanner Vision Tunnels Performance and Sortation Subsystems. So I'll go through all of those. It's actually a fairly simple setting. but you'll understand very soon what it means. Maybe just before I get started and talk about the details of this, let me just say that I am doing my master's on the engineering side, and I'm doing within the electrical engineering and computer science department, which is my background. I studied computer science in undergrad, and as such, I have an advisor doing funding within the ECS department, but also have an advisor within the Sloan LGO, MIT Sloan School of Management. So this Nikki covers that in my case. So let me just share a little bit more details about internships in general, just so you have a good context before I talk about mine. So every student, and it was mentioned earlier by Sharona, but every student will conduct a 6-month internship among one of the partner companies, Amazon being one of them. So you can have, in a regular year, maybe not right now, you can have internships all over the world, with the majority being in the US. Amazon actually hosted this year 5 different internships across various divisions in the US. And all of those internships are at the intersection of operations, but also your engineering discipline. So in my case, computer science and deep learning. So it's really at the forefront and at the frontier of those two. And again, very important, this is where you actually get to, yes, have an internship and kind of work in a real industry setting, but actually write a thesis based on all of this. Another thing that is important to say is not every LGO thesis includes machine learning or heavy analytics. There is a big trend, I would say, towards that. So if you're interested in data science, definitely you'll have a lot of opportunities there, but there's also students who may be interested in more traditional operations, lean, and so on, or something more on the engineering side, and they can also find projects that fit kind of better their interests there. So let me now talk about what I did. So essentially, what I was tasked to do was to find a good way to leverage computer vision models to diagnose various issues they had with their sortation system. Now, the sortation systems are essentially just what you see in the fulfillment process. So if you order a package, not a package, but an item online or multiple items, your order will be routed through a specific fulfillment center that contains those items. And someone will go, or a robot, depending on the site, and put those items together, package them, right, and send them your way. So that's the fulfillment process. But within that process, there's a very important step, which we call sortation. So this is where all your items have been packaged. They're in a nice box or some kind of envelope, and they're on the conveyor belt. And at that point, within that sortation process, there's a scanner, and I'll talk about it in a second, that takes pictures of every image to determine in what truck they should go, where they should be redirected to, and so on. And this is where my internship was to be focused on. So as part of this outbound process of the fulfillment centers, one of the main issues they have in terms of utilization, which is really important, especially now, obviously in COVID world, Amazon saw a big increase in demand as I was doing my internship over there. But one of the challenges they had was that those scanners, and you see one on the right here, scan every package and they find a shipping label. And then they identify the shipping label, read it, and say, okay, this package should go in truck X or truck Y or in specific chutes. The problem is this is really hard to do given this how fast those conveyor belts go and how many different types of packages in terms of size and so on can go through those scanners. So those scanners actually are not always able to correctly find and read the shipping labels. And at some sites, it could be up to 10–20% of packages are not read properly and end up in a manual separate chute where an employee needs to go and again manually debug what is happening and put it in the right chute. Multiply this across the entire network, you can imagine it's a massive amount of manual work that we wanted to automate. And the solution for this was to use computer vision and look at all the images from all of those scanners. And whenever there is what we call a no read, so the scanner did not manage to read a label, then we can use deep learning to assign a reason and say, look, something went wrong here, and the issue is there's not even a package in this carrier, or there's 3 on top of each other, or there's 1 but it's about to fall, right? And there's all those kind of reasons that can happen, and those reasons are extremely site specific, right? So a fulfillment center in California might have a different issue from a fulfillment center in Ohio, right? And so we needed a solution that would work well across the entire network and help every site understand what is going on about their specific site without having someone go through thousands of images manually every day. So that was the setting. You can see on the bottom right an example of a package that is not positioned properly. In this case, it is in what we call the bellows, so in between 2 carriers, and may actually be stuck there for the entire day if no one does anything. So that's the kind of issue that we can encounter some of the sites. More specifically, the thesis had very ambitious goals, and those goals were to actually develop an end-to-end product, meaning there is an entire machine learning component we had to develop, and actually I had to develop deep learning models. I'll explain it in a minute or two what kind of models I built for this, but to actually classify those images. But more than that, I had to kind of own a process from start to finish, from the site images to a fully functioning kind of small website and dashboard, which meant I also had to talk to users, understand how they wanted to visualize the results, and even conduct some pilots across the sites to make sure that this worked well, and all of the site operators were able to really get all of they wanted out of this, and it ultimately drive the financial savings that we're interested in from this. So it's really about building a product, which is really, really great opportunity, and something that in a typical internship, right, if you didn't have 6 or 7 months like we do within LGOs, you could never actually be there long enough to see a product from start to finish. And so that was the topic and the challenges I had to face. Now, how did I actually do this? Right? There's a couple of steps in the process. I'll focus a little bit more right now on the technical side and the technology, the deep learning, and so on. But as you can imagine, there were all kinds of non-technical challenges. I had to fly to all kinds of different sites and in person understand what kind of issues they have, and just talk to all those stakeholders. But from a technical perspective, what I also had to do was build that entire pipeline. And this is where actually interning at Amazon helps, because of all those resources that one can leverage. For instance, AWS, so Amazon Web Services, well known for their servers, obviously. So I could leverage a lot of this to create an entire pipeline to hold and kind of handle all the images from those all those sites, and actually perform some data augmentation, meaning you can take an image and transform it into 10 images by rotating it, applying some noise, and so on to get a richer data set. You can also generate all kind of additional features. So I used, and I'll show how it looks in a minute, but I used some techniques to actually highlight the edges in the image to kind of really make it clear where packages start and end. This is called Canny Edge, and so it's really powerful pre-processing technique. Similarly, I also was able to do all of the machine learning within the what we call the Amazon SageMaker environment, which is a really nice platform they have for to train and deploy machine learning solutions. So you can actually train all of your models there, but then again, in just a matter of a few clicks, deploy them to the cloud, so you can easily infer large data sets there and do all of this. And all my next slide will be about those specific models. I won't go into too much details. Happy to answer questions on this. But in short, I ended up using deep learning in a type of model called ResNet, which again I'll cover in short details next slide. It's really interesting opportunity there. And in the end, as I said, it was really important to actually have an interface. So I use a tool by Amazon called Amazon QuickSight, which is similar to Tableau for those who have used this, or Amazon, or all kind of BI tools, but essentially could take all of the results from the classification tool and then along with this kind of simple website could allow users to run the tool for their site at any time and see the results live. So let me talk about, and I know some of you may be very interested to hear about this and others not. So I won't spend too much time, but for those who are interested, just to see the kind of depth that we can go into for this. So I actually ended up creating 4 different models to classify 4 different types of causes for those incorrect reads, image reads. And all of those were based on what we call a residual neural network, so a ResNet. And it is a well-known type of neural network, actually published in 2015, I believe, for the first time. And there is a version that you can find that Amazon actually supports that has been pre-trained on the ImageNet dataset, which is a dataset of millions and millions of various images, dogs, cats, planes, and so on. And the model has learned all of those feature extraction process essentially through this. And what you can do through a process called transfer learning is use that pre-trained model and freeze most of what the model has learned, most of their weights, most of the layers of the deep neural network, and just retrain the last few layers for your specific use. And that's what I ended up doing. So essentially just teaching the model to learn about boxes and packages instead of cats and dogs, but still retaining the process kind of and all of the ability to extract features. And so those are pre-processed images to the left, right, where I could, in blue here, you see the edges that I said we could highlight through some statistical processes. As well, we could do the same thing for kind of those metal bars in between carriers to also help the model. And again, we'll go through what all of this means, but essentially, it is a neural network, which means it is a model, just as in a linear regression or any model. It takes as input, which is your image, does a bunch of things, bunch of layers that will extract kind of information, weights, and so on. And at the end, just returns you classification, right? It'll tell you, well, there's the box is upside down, or there's no box, or the box is not positioned properly. So you can really kind of learn a lot of different features and a lot of different classifications from such a model. So in the end, it was a really good success. Our accuracy was right where we wanted. So at the aggregate level, it was at most 2% errors. For the worst model, typically much less. So really helped each side understand what kind of errors they were seeing and really then be able to act upon this. So we piloted this at first across about 10 sites where we could help them understand what is going on. And in some cases, we identified broken equipment or all kind of operational challenges that they could act upon, and then reduce the number of no reads that they were seeing, and essentially then save money. So we piloted this and ended up fully deploying it to the entire network of hundreds of sites, essentially. Got really good feedback, and even as part of the internship, I got to write press releases and so on, to internal press releases to just get everyone's buy-in. So really great opportunity to see from start to finish an entire product. And now there's a lot of plan to take this to the next level, which we absolutely could by looking at things such as box damage or all kind of issues that we can also see on the conveyor belt. So really good opportunity for an LGO thesis, and really also a good opportunity to get to work in an environment that is such fast-paced and where we're able to deploy a product in such a short time frame. So that's all I had. Again, I realized people may have questions. I noticed a few in the chat already haven't had a chance to read, but happy to answer any questions about this project, about LGO in general, about Amazon, MIMO. We have, I believe we have time for questions now, right, Sharona?
Yes, we have lots of time for questions, so please put them in the Q&A chat, and we will get to as many as we can. To start with, I think there was a question for you, Felix, about did you have professional experience with ML and AI before LGO?
Yes, that's a good question. So I did, which definitely helped me kind of hit the ground running from day one in this internship. Not everyone does. I would say out of the ML internships right now within LGO, my guess is about half of them are conducted by people with previous experience and the other half by people who don't. So there's definitely opportunities there. But if you have that experience, it just means that you'll be able to do a lot more within your 6 months and maybe, as I said, see a product from end to end.
Great, thank you. And this is a question for Bruce or Felix, if you happen to know, but is the LGO project use case library publicly available currently?
No, it is not. We're just, we have some of them in. We're building out the library right now, and it will most likely only be available to members of LGO and MIMO.
Great, another good reason to think about applying to LGO then. So this is a question for Felix. Did you have to orchestrate the data collection, or was there any concern about collecting enough data to use for the training sets within the kind of constraints of the 6 months?
Yeah, so I was fortunate enough, again, that the data was somewhat readily available. So I had to work around kind of creating the pipeline to extract it, but it was not any like permissions issues or this kind of thing that can sometimes slow you down by weeks, if not months. So it was, for my case, it was a really well-scoped project, and I knew how to access data from the first week.
Great. So a question for Bruce. Intelligent supply chain solutions are primarily known on the outbound side. How can they revolutionize, or how can the inbound supply chains be revolutionized, which are known to be more fragmented and inefficient? So can you share any thoughts or interventions or potential or thinking about how you would answer this question through MIMO?
Yeah, so it's obviously a challenge, and there's a tremendous amount of impact there. We have several theses that have been done looking at the different components, but it does take a fairly highly evolved company to have that kind of visibility to their suppliers and their supply chains. A lot of the work is on exogenous factors, so things that are outside of the supply chain, but that will affect the participants in the supply chain, so they don't involve vendors giving you direct access to a lot of different pieces of information. But building out that digital thread is certainly something we're working on right now. And then there's just, once you have that information, there's lots of different techniques you can use to manage risk and take kind of preemptive actions.
Great. So another question for Felix. What are your aspirations or kind of goals post LGO?
It's a good question. I don't know yet. I have a couple of options, but I know I want to work at the intersection of data science, but also something more tangible. And that's what I wanted in the program. I like working in a more operations or retail setting, or so I'm definitely looking at the options in the field, but the exact role is still to be determined. There's a lot of different options.
Great. And so you came from the EECS department specifically, but can LGOs from other departments, also be active in the MIMO space and focus on machine learning and AI?
Yeah, and let me also answer. I think there was a question I saw earlier on how the internship matching process works. So maybe I can answer both at the same time there. So essentially, there's a list of projects that get published. At some point, you can either start your internship in February or in June. Typically, things are a little bit different this year. And there's a list of projects such as the one I got, but you may have a project on kind of deep learning at a pharmaceutical company, or you may have something around pure operations. So you see all those different projects and for which departments they are open for. Typically, machine learning projects are open for most departments. There are people in my class with great machine learning experience, and they're studying in civil or in mechanical engineering. So they're definitely open to everyone, and it's really just a matching process where you'll interview with the internships that interest you. You'll rank them, they'll rank you, and then everyone gets assigned an internship with one of those 25 or so partner companies that the program has.
Great, thank you. And just so everyone knows, this will be recorded and posted on our YouTube. So if you want to kind of look at any of the slides more closely, there will be opportunity to do so. Let's see. So Felix, can you share how coursework that you took before your internship kind of helped you during the internship? So it sounds like you had a Feb start, so you only had the LGO core and the Sloan business core, but can you kind of speak to how those skills and new knowledge translated?
Yeah, absolutely. So I think two things were quite helpful for me. So I only had 2 semesters before, so I would say some of the classes I'm taking now would have definitely been helpful a year ago for this. But some were pretty helpful. We do have a machine learning course over the summer, at least did. I think things are always changing a bit there. And it was just a very good refresh for me, although I already had experience in the field. But I think for a lot of people who have internships in data science and didn't have that knowledge before, it was really helpful. I also took over the fall a statistics and deep learning course, so that was also helpful. Even though it wasn't on computer vision, it really helped just kind of frame all of those problems for me.
Great, thank you. So Bruce, at the start of your presentation, you mentioned finding the shortest path from data to impact. What advice would you give to someone who is trying to convince upper management in implementing more IoT devices on the shop floor and real-time analytic tools?
Start small with a business case. You know, I hear a lot of people say, oh, we can't afford to collect all the data, or we don't have the data. I think it's like any other project in manufacturing. It has to have a business case. It has to have an impact. So start with a really impactful problem, and then build the business case around how you could solve it. And that's part of why we're trying to build the use case library, so that someone, say they have a similar problem, can point to that use case, and then the underlying thesis, the use case being more digestible for their management. But to show, okay, they had a problem similar to ours. Their goal was to improve the same KPI, key performance indicator, that we're trying to improve. And they were able to show a 10% improvement or 5% or whatever the number works out to be. And in our case, that works out to, X dollars. So, now you can kind of get the cost saving piece of it. And then, the costs are depending on, really, are you getting an off the shelf solution from a vendor? Are you building it using tools like Felix talked about from AWS or Azure? There's lots of tool packages out there. Hopefully you don't have to build it from scratch, because there's, using, open source libraries, but many people do. So it's just that whole continuum. But basically, start with an impactful problem that's not too big, because if it's too big, you'll scare people off. If it's too small, they won't care. And that's relative to your business, and then build a business case around it. And that's just where you start. Don't do a deep dive into the technology or any of that, and don't try to collect all the data. The sooner you can determine which features or which data matter, the better. And that can be just based on some pure physics. Collecting all the data and throwing it into some algorithm, as Felix will tell you, really doesn't work.
Thank you. So a more technical question for Felix. Could you have used GAIN, or was there any advantage to using ResNet as opposed to GAIN?
Yes, it's a good question. Without spending an hour on this, I'll say that, so for those, so it's actually, suspect meant GAN, or GAIN is a type of network, it's less common. But basically, this is a kind of model where 2 neural networks will challenge each other, and one will generate images, the other will classify them. And this is a pretty common approach, but a little bit less so for this kind of problem. There is some times where the classification portion of a GAN may be better than typical ResNet, but it's not always the case, and also comes at the expense of, I think on average, something like 6 times slower training time. And so there's definitely a lot of downsides to it. We may have considered other options, though our accuracy was not where we wanted it to be. But from a purely business perspective, the accuracy was good. So why look for something that would be potentially slower or longer to do?
Great, thank you.
And just a quick point on that, if anyone who was really watching the examples I put up for the ion implantation example that we did during the student research forum, I did show a screenshot of a GAN being used. I will tell you that's at this point future work. And right now they're using, support vector machines and Parson window classifiers, which are much more stable, very quickly, they're explainable, they're understandable, they're easier to train. So we're starting there, and we will ultimately use a GAN to see if we can eke out some kind of modest improvement, but we want to make sure we get some points on the board, if you will, so that we have some solution rather than kind of the perfect solution that nobody understands why it works and it takes 10 times the compute power to run.
Yep. Let me just say, actually, though, one of my classmates in his internship is using GAN, so it is not. There are definitely uses. It just really depends what you're trying to do, but it is out there.
Thank you. So Bruce, there are a couple of questions about your experience as an LGO alumni, kind of in this field, and kind of what your experience and the skills you gained from LGO kind of helped guide you through this field.
Yeah, I think the skills. So just to totally date myself, Excel was a power tool when I came back to LGO. And that's actually what I wrote my thesis in. Now, before that, I was doing what was then called AI, so symbolic processing, is all list-based code, and this was integrated into a 3D solids modeler and a surface modeler. So that was my background before coming to LGO. I think that what LGO gives you is that good balance between business and technology, and so you can see through a technology what its strengths, its weaknesses are, what its limitations are. You don't view it as magic, as I always say, and Felix kind of said this, machine learning is not magic, it's just math. It just math executed billions of times, so you get kind of a whole different perspective. So anyway, it lets you see that, but at the same time appreciate the business aspects of it and really understand. One of my favorite courses in LGO was Voice of the Customer, where we just spent a lot of time understanding customer needs and then very systematically mapping it back to how do you meet that need with an underlying technology. And I think that's really super important for anything, and especially things which seem complex and magical, like machine learning, to really kind of make that direct line from, as I said, from data to impact, or from problem to, some result.
Great, thank you. So I think we will end there just so that we can wrap up on time and then let people get on to the rest of their day. But I want to thank you both again so much for being here today, for sharing your work. It's clearly really exciting. And I think that we had a ton of interest from our audience today.
And I just want to say, I wish you all the best of luck in your decision. I went through the program 30 years ago. The fact that it still exists in its form, and we've got students like Felix that are coming in, and alum, and I'm not the only alum coming back to help the program. If you'd been on the call last night that Sharona did, you'd see many more alums that are just engaged and active and really want to help the program and the students move ahead, because we do have a real passion around industrial competitiveness, and we know how important it is. You know, we're going to add another 2 billion people. They're all going to want the lifestyles that we have. And if we don't get more efficient at converting natural resources into human well-being, the planet won't take it. So that's really what we're all here for. So good luck in your decisions. Thank you for joining us.
Great, thank you. So please check out future LGO events. We are having them often and all virtually now. So if you're interested to hear about any other aspects of the program, please check them out. Our round 2 deadline is coming up on December 1st for the class of 2023. So if you're interested, definitely look into our application process. And of course, check out MIMO, and have a great Thursday. Thank you all for joining us.